So for random access to work, there should be two activities. First one is to do a seek, and second one is to do a transfer. These two activities are needed. So we looked into that. So what we figured out that the seek time in the past 30 years, okay, the improvement is less. Okay, transfer rate has increased. Okay, today 100 Mbps transfer is very easy. That is from disk to memory is faster. Okay, so now if this is the case, what happens is that of these two things, the seek time is going to, for any big operations, if for any big data operations, seek time is going to be the limitation. Seek time determines how fast it can be done. Okay. So since seek time has not improved in the past 30 years, so your any operations, anything that you advances into hardware or any other thing, it's always going to be depend upon the seek time. And for some reason, suddenly what happened is that over a period of time, there was always a need for RDBMS. Okay. Now suddenly what happens is that there was a huge data growth. Huge data growth was there. So with huge data growth, there was two problems. So one is you had the problem of storing data, and second one is the problem of processing data. So to store data, people came up with a distributed file system. This is what we call as a Hadoop distributed file system. And to process this whole data is where Hadoop MapReduce came into picture. Okay, this thing was done. But what happens is this has a limitation. There is a limitation. Okay, Hadoop is good for storing large in the sense of huge data in petabyte scale. And it can do the processing on huge files. The limitation is, okay, it can do only batch processing. Okay, so no matter how much data it is possible, and batch processing, and then that is data can be looked only in sequential manner. Okay, and entire data set has to be looked even for simplest job. Okay, so this is the limitation. Okay, so people when they created huge database, huge systems for storing and retrieving and all kinds of data, then people wanted, okay, it is fine that I can store huge amount of data. I'm fine with even batch processing, but I want, so what happens is that it's like this, okay, huge data after processing produces huge data. Okay, even this data has to be sequentially analyzed. So this is where people wanted a change. Okay, people said that at least the results of processing I should need something like an RDBMS. That is, we can look into any point of data in order of one lookup time. Okay. Now people said that since so this is what the requirement is. Okay. So this is where the projects like Cassandra, projects like HBase, projects like Dynamo, projects like MongoDB, projects like CouchDB, so many things. Okay, these are all examples of NoSQL databases. Okay, which means that it not only stores a huge amount of data, but also provides a capability to look into those data in a random fashion. Okay, so is that clear that from where this overall? So I'll tell you the reason. So you want to understand that why I call Hadoop as a sequential system, right? Okay. So let's talk about a simple thing. Okay. Hadoop. Okay. So what is Hadoop designed for? Hadoop is predominantly designed for processing huge amount of files. Okay. And huge amount of files can be processed only if you are able to divide the files into multiple blocks. Okay, and then process the individual blocks. Okay, so this is the concept. Okay, this is a conceptual model. So what happens if this is a big file to be processed? I have to split this file like this. You can say B1, B2, B3, and B4. Okay, so the first problem is that if I have to split this and then do it, I can do this only when my whole concept of processing this file can happen in a sequential manner. Okay, if it is going to happen in random manner, I may not know where to start. Okay, so if my problem is like if I have to do randomly, I can't split it first of all. So first of all, to split individually and process it, I need to do a sequential processing. So I split this. Okay, so now B1, B2, B3, B4 is there. This is given to computer 1, this is given to computer 2, given to computer 3, given to computer 4. Okay. What can also be there is this B1 itself can further be divided into B01, B02, B03. Okay, maybe multiple threads can look into this. Okay, so multiple threads can look into that. So what has to happen is that to split and process, I need to divide and then work on it. The processing should be sequential alone. Okay, that is one aspect of it. The second aspect is all I'm doing is analytical. Okay, so the thing is that predominantly when I see, so it is like an aggregate operation. Okay, so aggregate operation. Say for example, a simple example will take sum. Okay, to do sum. Okay, say for example, if I have an array like this. Okay, sorry about my drawing. Say for example 1 7 8 6 2 1 3 2 1. If I have an array like this, and to count the sum of this array, I have to visit all elements. Okay, and when I have to visit all elements, okay, when I have to visit all elements, it's good to do sequential. Okay, so I start from here and then I keep reading like this. Okay, so what happens in a typical RDBMS is, that is why you have an array kind of a data structure. Okay, so you read this whole thing into memory and then keep it and then reading it. Okay, so it is one single read and then do it. Say for example, if this is not just 10 elements, imagine there is 1 million elements. Okay, so one in the disk, this 1 million stored in this disk, it may not stored completely into one block. Okay, this 1 million entry in the disk will be stored somewhere here, 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 here. So many places it will be kept. Okay, so the operating system has to do multiple seeks and transfer this. Okay, so it has to do the multiple seeks and transfer to do this counting. So in Hadoop, what people decided is that, okay, because it is a disk, it has to do this. If I am doing like this, I will be spending all my times in this seek, which is the slowest component. Okay, it is like this. In the marathon, your fast is determined by the slowest runner. I mean, not in the marathon, in what you call it, the relay race. Your speed is decided by the slowest runner, not the fastest runner. Okay, like what lots of people may think. Okay, so if the slowest runner decides the overall speed. Okay, because no matter how much the other person performs, the slowest runner is going to determine how fast the team can progress. Okay, so this designer wanted to remove the slowest runner. So what they thought, anyway I'm going to do processing all the content, I don't need this disk. So they wanted to convert this disk into tape. So the concept of, so there's a new terminology called disk as tape. So what they wanted to do, they wanted to do a bulk transfer. So big files are divided into bigger blocks of 64 MB. Okay, and they are kept. Okay, and the processing is not going to do a random seeks. The processing is always goes to, it starts from here, reads the entire 64 MB, takes it into memory and process. Read 64 MB, read 64 MB. And inside it, it does only a sequential read. Because according to Hadoop, your data is nothing like a list. And to do any activity, we have to look into entire data set. Okay, and if I have to do the look into entire data set, what is more efficient way of doing it? Sequential. This is the most efficient way of doing it if I have to read the entire data set.